The Holenhaps. Once upon a time, there was a peculiar family called the Holenhap. The Holenhaps composed of Father Holenhap,
Hey.
Mother Holenhap,
Hello.
Brother Holenhap,
Yo.
Sister Holenhap,
Hi.
and baby Holenhap.
Hello.
Though their ages are different, their sizes are the same. But the thing about Holenhaps is that they can shift their bodies to divide into two halves or combine into one whole. Holenhaps. Although the last time they were whole was only when they were born. Why would you even want to choose becoming a whole if you can do the chores while sleeping? Play ping pong alone? And do duets in solo while being in a half state? Another odd thing about the Holenhaps is that they are always moving and they casually bump into the walls of their house, sometimes thrice a day, many times twice. They really don't like bumping because it hurts them. Their house is also a bit strange, for it changes its size depending on the weather. When it's sunny, it's wide, but when it rains, it shrinks. One day, a big storm came. This shrank the house to the smallest size they ever experienced. They were bumping into the walls 10 times in an hour, and this made them very weak. The pain was getting worse, but the bumping didn't stop. The Holenhap house was very chaotic. This made the father speak up his thoughts.
I hate to say this, but the time has come. The only way to save our family from this pain is to combine our halves into a whole.
And each half of their bodies merged with the other half. The bumping lessened and the pain slowly faded. They regained their strength and the house became more peaceful. The family learned that there were also benefits of being whole. Many storms passed, but they already knew what to do. And the Holenhaps live happily ever after.
So moles and pressure. The pressure of a gas depends on the number of molecules. As we can see in the diagram, on the left side there are fewer molecules and on the right side there are more molecules. So in the right side there are more molecules, so the interaction between gases and the frequency that they bounce off the wall is greater than compared to the left side. So that means that the gas on the right will have twice the pressure as the gas on the left. So what if there is a disturbance in the system? Le Chatelier's principle states that a system at equilibrium, when subjected to a disturbance, tends to respond in a way that minimizes the effect of the disturbance. In the context of pressure disturbances, for compression, the reaction will tend to adjust to minimize the increase in pressure. For expansion, the reaction will tend to adjust to minimize the decrease in pressure. So for example, the equilibrium reaction in ammonia formation. So in the reactant side, there are 4 molecules, and in the product side, there are only 2 moles of ammonia. So there are greater moles in the reactants compared to the product. Compressing this system, the pressure increase will favor the product since it has fewer molecules. So nitrogen and hydrogen in the system will form ammonia. On the other hand, when the system is being expanded, so there will be a decrease in pressure, and this will favor the reactant side. So ammonia will break down to nitrogen and hydrogen molecules.
The Holenhaps represent molecules A that form two molecules of B. The forces that they exert on the area of the walls in the bumping situation are what makes the pressure. Their house could represent a vessel with a piston, which explains the changes in volume. Thus, when the volume decreased, the bumping was more frequent, resulting to a higher pressure. And according to Le Chatelier's principle, these molecules would tend to react in a way that the effect of the pressure is minimized. The Holenhaps merged together to lessen their population from 10 to 5, or the reaction favored the formation of A from the molecules of B to achieve the least pressure increase possible.